In this lesson, we're going to look at experimental errors. And by the end of it, you should learn the types of errors, how they may occur, and how to reduce them. We're also going to work on the assumption that you know how to write up an experimental procedure. Now, the first thing that we're going to look at is what is an error. An error is any unavoidable circumstance that may occur during any experiment that you are conducting. And the two categories they will fall under is either a random error or a systematic error. First off, with random errors, what we are dealing with is errors that are unavoidable due to the experimenter themselves. It all has to do with how the experimenter performs the experiment or how the experimenter reads the instruments. Alright? So the two types that fall under this random error that we're going to look at is the reaction error and the parallax error. The reaction error is simply an error that occurs during the timing of an experiment. And say, for example, you're required to time how long a running person takes to cover 100 meters. If you're supposed to start the timer at this point here, you would end up starting the timer at this point. Or if you're supposed to start the if you're supposed to stop the timer from at this point, you will probably stop it at this point. One way to reduce this is by simply taking an average of this over and over, and if you do it multiple times, the average will tend to make your reaction errors fairly consistent. You can also time your reactions by stopping and starting a stopwatch and just simply minus these values off from your time values that you take. Alright? So averages is a good way to actually reduce this type of random error. Alright? And next type of random error that we'll look at is the parallax error, and this is just simply how you're going to view an analog scale to take a measurement. Now, the parallax error occurs because there's a certain amount of distance between the pointer that you're going to have and the scale that you're going to use. In this diagram here on the left hand side, we will have two observers observing the same pointer. But what we're going to do is we're going to take the scale from one point and we're going to move it closer. Notice that the red dots move closer and closer together as they come, as you bring the scale closer and closer to the pointer. Alright? So this is one way that we can reduce the error due to parallax, and that is reducing the distance between the pointer and the scale. Another way, if you notice it, that the green dot here, this line here, has the exact same value no matter where you move. Alright? How you move the scale. This is due to the fact that the line of vision is at 90 degrees to the scale and it passes straight through the pointer. By using this, you can actually reduce the parallax. And you can adopt this in a situation, for example, measuring the amount of fluid here inside of a measuring cylinder. And what we say is we take the bottom of the meniscus, which is the pointer, and we line it up with the scale at right angles so that we will be able to get the correct value. Notice that here has a particular angle and here has a particular angle which will affect the value that you are obtaining. Alright, so to recap that, the ways that we reduce our parallax errors by having the line of vision that is perpendicular to the scale and make sure that it's running through the pointer and the scale and it meeting the scale at right angles. And we can also reduce the distance between the pointer and the scale, and the last part is we can add a mirror strip behind the scale or below the scale. Alright, say for example, this is what you have. This is the mirror strip here, this is your pointer, and this here is the image of the pointer inside of the mirror. As you are lining up the image with the pointer, what is going to happen is that the image is going to disappear behind the pointer itself. And as the image disappears behind the pointer, what it's going to mean is that you are viewing the scale, you're viewing that pointer at right angles. You're viewing that scale at right angles, which means that you are reducing the parallax error that you have. Alright? So the other type that we talked about is systematic, and systematic errors are errors due to the experiment that is conducted, how the experiment is conducted, and this is sometimes due to the instruments. And one type of error that is due to the instruments, systematic error that is due to the instrument, is the zeroing error. The zeroing error occurs when there is a reading on the instrument when you are not measuring anything. Alright, and two ways that you can either deal with this, is either by measuring that zero error and subtracting it from each reading that you take, or you can zero the instrument before you use it to take any readings. So if you have any questions or comments about this, you can send me a message or you can simply leave a comment with the video below. Thank you.